Hey guys, welcome to the video for 5B. In this video we'll be going over basically combining our understanding of recurrence relations, so what we did in 5A, the structure of it with initial terms and how we're going up or down by certain things. We'll be combining that with our financial concepts. In particular today we'll be looking at simple interest, flat rate and unit cost. Simple interest we're very familiar with. I'm not going to define what simple interest is because we should be quite familiar with that by now. It's when we're just going up or down by essentially the same number. That's the exact same with our recurrence relations. We're basically going to create a recurrence relation where we're going up by a certain value, but it's just going to be in financial context, so looking at simple interest. Alright, so it has a particular structure to it. Normally we have an initial value. Now typically in financial context, including simple interest, we represent the sequence with a V. So we talked about last time how the sequence could be represented by A, B, G, whatever. But typically, most of the time, you'll notice it's represented by a V. So same thing, V0, like the 0th term, or our initial value. And then we got Vn plus 1 is equal to Vn plus D. Now the Vn plus 1 and the Vn we've seen before. The D part is something that's new in this exercise. Basically, that's how much the investment or the loan or whatever is going up or down by. So if it's plus, it's going up. It's like an investment. If it's a minus, it's going down. Could be a loan or some other situation. But that essentially means difference. It's what it's going up or down by. Simple interest always goes up or down by the same value. That's what makes it simple interest. Because the interest is just calculated on the principal, the initial amount. So it doesn't change. So it's pretty straightforward. But we do have a way to calculate that D value when we're not given it. So if we're not given the value that it's going up or down by, we can use this formula. It's just the rate, or the R, over 100 times by the initial. So D equals R divided by 100 times VO. That gives us how much it's going up or down by. So we'll just do a quick example. Let's say, go $500. Right, $500 is invested in 8% interest rate. It's not asking me to calculate the amount of the investment after 2 years or whatever. We're just going to set up a recurrence relation. Alright, the initial is pretty straightforward. That's our first value that we need to identify. In this case, it's 500. Now, before we write out our full recurrence relation, we do need to calculate this D value, the difference. So to work that out, it's the rate, in this case, which is 8 over 100 multiplied by the initial value of 500. If you type that into your calculator and work that one out, you'll get 40. So, if we put that into the formula, that's what we get. initial value of 500, and then our investment or whatever it is going up by 40. And that's the answer. So if I wanted to work out, for example, V1, it would just be V0 plus D, which in this case is 500 plus 40, which is we hopefully can work out is 540. That'll be 580 and then 620. That's the beautiful thing about simple interest. That's the easy part about it. It's just going up or down by the same value. You don't have to keep recalculating like with compound interest. It's always going to be the same value. That D value does not change. Make sure you pause the video and take notes where you need to. All right, the next part that we're going to look at is flat rate. All right, that is basically when the value of an item or something decreases based off how much it's used. So like a car might decrease in value at a rate depending on how many kilometers it does or something like that. That's when an item or asset how much it's used. All right, because I don't want to start the video again, I've just realized I've done the wrong subheading there. That's not flat rate, that's unit cost. Sorry, it's late when I'm doing this. I'm getting my subheadings all mixed up. Sorry, that's unit cost. However much the units is used, that's how much is decreasing in price. All right? I'll let you know before I end this lesson. All right, so let's just do an example because these can be represented with recurrence relations. Let's go with that example. All right, let's say, Hannah carpentry apprentice. She buys a grinder for, let's say, $200. Which decreases in value by, we'll go 32 cents each time it's used. All right, so I'm not going to specify anything with this question saying how much is it worth after 100 uses or whatever. We're just going to set up a recurrence relation. We're just practicing getting it into the right form. Pretty much the exact same as this one though. With unit cost, it doesn't change. You're still doing the same thing. You're identifying the initial value, in this case 200. The only thing this time though is we don't have to do this whole calculation for D. D is essentially given to us. D is how much it's either increasing or decreasing by. In this case, it's decreasing by 32 cents each time. So we can just literally write that our value for D is 0.32. So our full recurrence relation, initial value of 200, as well as the full relation, just Vn minus 0.32. That's it. If I wanted to work it out for one use, I would just subtract 0.32 from the initial. $199.68. If I wanted to work out V2, I would just take away 0.32 and keep doing that over and over again, depending on what the question was asking me. And yeah, that's pretty much it for this exercise. Like with the last one, the questions do get a bit trickier as they get more wordy. Make sure you're consulting the worked examples in the exercise. It's up to you guys to have a look through those ones. But obviously, your teachers will be on the meet throughout for you to help.